Hello, and welcome to day 3 of graphing absolute value functions. So in the past 2 days, we've talked about numbers that have been here after x. Okay, one of them is a vertical change. So here we have a vertical change, meaning the vertex goes either up or down. Then we started putting numbers here. And if they were right here inside the absolute value and after x, we said this was a horizontal change. And we said that that affected it either going left or right, affected the vertex, either left or right. Okay, so this is affecting the vertex, vertical change or horizontal shift. Okay, so now if you look here in this first example for today, we have a number in front of x, and how does that affect it? Well, let's think back to, we said that this was somewhat similar when we first talked about this to y equals mx plus b. Y equals mx plus b. And we said this number in front of x represented the slope of the line. So we have a number here in front of x. So how is this going to affect the slope or the slant, or whether it's the parent function? Remember, our parent function is y equals the absolute value of x, where there's nothing after x. Your vertex is here at 0, 0. And then this number that we're assuming here is going to be a 1. So we go up 1 over 1, and we call this the parent function of absolute values, and we're talking about always comparing it back to this function. Does the vertex stay here, or does it adjust horizontally or vertically? And that's what we were first talking about. So now, what happens when we put this number in front? So let's plug in this -2. So we have 2 times the absolute value, and we're putting in a -2. So we're going to have the absolute value of 2. So 2 times 2 gives us 4. So we have the ordered pair, -2, 4. -2, 1, 2, 3, 4. Okay, now let's try the next one. We're plugging in a -1. So we have 2 times the absolute value of -1. The absolute value of -1 is 1. So 2 times 1 is 2. So we plugged in a -1 for x, and what came out was a 2 for y. So we go -1 up 2. Okay, now let's plug in 0, 0. So you have 2 times the absolute value of 0. Well, 2 times 0 is 0. So we have the ordered pair 0, 0. So we're right here at that same point, 0, 0. All right, now we're going to plug in a 1. So 2 times the absolute value of 1. So the absolute value of 1 is 1. So 2 times 1 is 2. So we have the ordered pair 1, comma 2. Over 1, up 2. Well, it looks like our vertex is still at 0, 0, which makes complete sense because we don't have any numbers here after x, so we are not adjusting our vertex. All right, let's plug in this last number here. And the last number that we have here is a 2. So 2 times the absolute value of 2. That's not working so hot. I'm going to grab a different color. Maybe I'll grab this orange. Erase this, and I'm just going to use this orange 2 instead. All right, so we're going to plug in 2, and the absolute value of 2, absolute value of 2. So the absolute value of 2 is 2, and 2 times 2 is 4. So we have the ordered pair 2, 4. 1, 2, 1, 2, 3, 4. And now we can make our v here. And if you look, if we compare this new v that we just made to the parent function, we say that it is skinnier. Okay, it is stretched out. So this is a stretch because S-T-R-E-T-C-H, we are stretching it out from where that parent function, that red one is, it is getting stretched out or pulled up. So now let's look at this when we talk about it in terms of slope. We would always write that as 2 over 1. So we would say we were going up 2 and right 1. Well, let's check from our vertex. Do we go up 1, 2, and then right 1? Up 1, 2, right 1. That's exactly the same slope, what we were talking about when we did lines. So this number in front, 2, made it stretch out because we went up 2 units, then over 1, up 2, over 1. And remember, we have to go in both directions because this is an absolute value. All right, let's try this next one. So we have a -3 in front this time. Okay, so how is that going to affect us? Well, let's think what we were doing over the last 2 days. Whenever we had this negative in here, instead of our V opening up, didn't that negative make the V open down? And now what is that 3 going to do? To me, that 3 is going to stretch it out. So it's going to open down and it's going to stretch it out. Okay, again, there are no numbers after here, so that's telling me that I'm probably going to have my vertex here at 0, 0. So let's plug in some numbers and see if what we said happened, which we're saying it's going to open down and it is going to stretch it out so that it's going to be 3 over 1. Okay, so let's see what happens. So -3 times the absolute value of -2. Well, the absolute value of -2 is 2, so -3 times 2 is -6. So we have that ordered pair, -2, -6. So -2, 1, 2, 3, 4, 5, 6 goes here. All right, so now we're going to plug in a -1. The absolute value of -1 is 1. So -3 times 1 is -3. So we plugged in a -1 for x and we got out a -3 for y. So -1, 1, 2, 3. All right, we're going to plug in a 0. So the absolute value of 0 is 0. 0 times anything is 0. So we have the ordered pair 0, 0. And we kind of thought it was going to go through that point. And let's see what happens now. Does this pattern keep continuing and I get a point up here? Or does something else change? So we're going to take the -3 times the absolute value of 1. And the absolute value of 1 is 1. -3 times 1 is -3. So we have the ordered pair 1, -3. 1, -3. Well, it didn't keep going as a straight line, which totally makes sense because we have this absolute value here. So we know at some point in time it is going to be making a V. So I'm going to get rid of that. So now what happens here when we put in a 2? The absolute value of 2 is 2. So -3 times 2 is -6. So we have the ordered pair 2, -6. So 1, 2, 1, 2, 3, 4, 5, 6. And we end up with a V, just like we thought we were going to. The vertex did not move. It stayed at 0, 0, which is what we thought because there's nothing here. It did not adjust horizontally or vertically. It opened down like we thought it would because of this negative. And now we thought it would be down 3 over 1. So let's see. From this vertex, 1, 2, 3 over 1 over 1. Okay. 1, 2, 3 over 1. 1, 2, 3 over 1. It did exactly what we thought from the patterns, okay? Because math is all about patterns and us figuring them out. All right, let's try this next one and see what happens. So here, we again have no numbers after x. That is telling me that this vertex is going to be right here at 0, 0, like that parent function. Now I have a fraction here in front, a number between 0 and 1. Okay, so between 0 and 1, a fraction, something less than 1. All right, so what do we have here? Negative. So I am going to put in a -4 here, because if I'm going to take a half of something, I don't want any odd numbers. So I'm going to take half of 4. So I'm going to put a -4 in here. So what happens when we take the absolute value of -4 is 4. So what's 1/2 of 4? And we get out a 2. So we have the ordered pair, -4, 2. So -4, 1, 2, 3, 4, and we're going to go up 1, 2. All right. So if we had to guess, we already said the vertex is going to be at 0, 0. This is a positive number, so I'm guessing that my vertex or my V is going to open up. Okay, now if we're trying to think of this as being slope, okay, slope, so we're going to go up 1 and over 2. And remember, I can do over because I'm going to go left and right. So let's see if that's what's going to happen. So because this is a 1/2, I'm only picking even numbers. So my next number I'm going to pick is going to be a -2. So 1/2 and times the absolute value of -2. The absolute value of -2 is 2. And what's 1/2 of 2? It is a 1. So we have a -2, comma, 1. So -2 up 1. All right, let's put a 0 in here. So if we put a 0 in here, 1/2 times 0, anything times 0 is 0. So we're going to have that ordered pair 0, 0. Okay, now I'm going to pick in the positive number 2. So I have 1/2, and now the absolute value of 2 is 2. So 1/2 of 2 is a positive 1. So I have that ordered pair 2, 1. So over 2, up 1. All right, and the last number we're going to plug in here is a 4. So 1/2, the absolute value of 4, so I have 1/2 times 4 is 2. So I have the ordered pair 4, 2, 4, 2. And here is my V. So let's see, did it do what we thought it would do? Up 1 over 2, up 1, and then over 2, up 1, over 2. Exactly what we thought. Up 1 over 2. Remember, we have to go both ways because we know this is going to be a V. And it opened up because that number was positive. All right, let's put all of this together and see if we can do this next problem without making a T-chart. So if I'm guessing here, I've got no numbers here. So because that, we're going to have our vertex here at 0, 0. Now, I see a negative right here. That negative is telling me my V is going to open down, and here's my slope. So I'm going to go down 1 because it's going down, and then I'm going to go over 2. So down 1 over 2, down 1 over 2. And remember, you have to go both ways from wherever your vertex is so that you can do this. So down 1 over 2. Down 1 over 2. And that's what our graph would look like. All right, let's try the next one. All right, so again, we have absolute value. There's nothing after it, so that's telling me my vertex is going to be here at 0, 0. This is a negative. That negative tells me my V opens down. So now with this being a -1/3, this means I'm going to go down 1 over 3. So from my vertex, down 1 over 3, down 1 over 3, down 1 over 3. Make sure you go both directions. Now this right here, the other one, when it went skinnier like this, we called this a stretch. We were stretching it out. This is a stretch. What this is called right here, when it goes wider, this is called a shrink. Okay, so I've got one more problem here. See if we can write the equation. All right, your vertex is here at 0, 0. So I need a number to go in here inside the box. I have nothing after because I'm here at 0, 0. It's opening down, so I know that this number right here needs to be negative. So what do? I'm going to count down 1, 2, 3, 4, and it goes through right at this point over 1. So I went down 4 and I went over 1. Well, 4 divided by 1 is just a 4. So that's why I have a -4. Okay.